Clearly, in places like California and many parts of the United States where you have a system average load factor that's about 50%, is a problem. You wouldn't run an airline effectively at half full all year, only to have all the airplanes full on the Thanksgiving weekend. That's effectively how the electric systems run today. That's not an efficient use of that asset. Billions of dollars. I mean, EEI is estimating that over the next 20 years, Edison Electric Institute, which is the trade association for the investor-owned utilities in the United States and into North Canada, they're projecting $1 trillion of investments going to be needed in modernizing the grid, both replacing the basic infrastructure, much of which has been out for 40 or 50 years, as well as expanding the system to adapt to the growth in the United States. And so you have a lot of capital that's going to be expended and needs to be operated efficiently, that's for sure. What we look at Cisco is that all of this requires a communication network that needs to be put in place to be able to connect these sensing devices, these intelligent devices that are increasingly going to be part of this $1 trillion investment that is going out. When we talk about energy technology anymore, it means that there's also an element that is intelligent that's built in. It's very difficult today, whether we're talking about a smart meter or we're talking about a circuit breaker or we're talking about a transformer. These devices anymore are increasingly having sensing devices built in. There's some level of intelligence. There may even be some sense of analytics built in to be able to manage these devices, manage the grid more efficiently. They all need to be connected. Now, when we start to shift to the consumer side, whether it's the residential, the commercial, or the industrial, clearly there's been a proliferation of sensing devices that start to feed the data to the kind of analytics that were talked about. That connectivity is required to be able to scale at a massive level, not unlike what was done in the internet, and we're clearly seeing that in this space. And it is a need to be, as Pat said, for software, the same thing exists for networks. We need large-scale, proven network designs, modern networking technology and capabilities and architectures applied to these problems, because we're talking about tens of millions of connected points, just even for a utility like Southern California Edison. 5 million meters. Just 2 devices beyond that meter that need to connect starts to get you into some very large-scale problems that utilities today, even like a Southern California Edison, doesn't have any more than 50 or 100,000 devices connected. So to go from 50 or 100,000 devices to 10 or 15 million in the span of 10 years is a dramatic change